Welcome to Chem 242 review stream. We're going to have something a little bit different today. Go ahead and say hi to everybody.
Hello.
Hello.
So the plan for today is we're going to go over the last two quizzes that were due. That you guys have already done. Let me go ahead and get a link for the folks that are in Discord. And then we'll get started. My computer's arguing with me. You're trying to do too many things at once. Yeah, hopefully my CPU fan is not too audible. It's really going right now, though. I can for sure hear it. All right, so I was thinking we can do the carboxylic acid quiz real quick. That one's short, probably a little bit shorter. What do you guys think?
Oh, sounds good.
Okay. All right, so let me switch the view, and then we will get started. So I had it on browser full. Here we go. Actually, I'm going to pull the zoom in here now. Now that I know how to do it. All right, so this one. There we go. Hello, everybody. I can probably make it a little bit smaller. All right, so for the first one, what do you guys think? What did you guys get for the first one? So what is the correct structure for succinic acid?
C.
C, yep, that's correct. Yeah, that one was just a matter of just looking at your nomenclature rules.
Yeah.
Number 2, which of the following is the strongest acid?
E.
Yeah, so what was the concept that we're exploring in this question? You guys remember? Like, what is the concept that's being tested here?
Electron withdrawing.
Yep. So basically, electron donating versus withdrawing effects.
Yeah.
So remember that if you have withdrawing groups that are away from the acidic H, then typically what happens is they will increase acidity. But if you have donating groups, you decrease acidity. All right, next one here says rank the following acids in strongest to weakest in order of acidity. And hang on, bring up the choices here. Yep. All right. So I do have the correct answer displaying there. So it's the same kind of thing here we have withdrawing groups versus donating groups. So it should work out that nitro being your strongest withdrawing group, that'll have the most impact, followed by 4, which is another withdrawing group, and then it goes 3, then 1. 1 being the strongest activator. And if you guys have any questions now, you're more than welcome to ask as we go along.
You said 1 being the strongest what?
Activator. So because 1 has the strongest activator on it, it makes it the weakest acid. Is that a question? I'm not sure. It's frozen.
What's frozen?
Yeah, they're saying the broadcast is frozen in Discord. We're going to have to keep going. Hopefully it's not an issue that we had that last one where the audio was all out of sync.
Oof, that was
Brutal.
All right, so number 4, this is an oxidative cleavage. So it's a matter of counting your carbons and then recognizing where the carbonyl groups are going to go. So what did you guys get for this one?
B.
Yep, B is the correct answer. So I did want to point out that in my class, I go over, you can change the second step on this ozone reaction to basically oxidizing conditions, and you have one less step. I believe what I show in my class was H2O2 and hydroxide. We'll give you the oxidized product, which is B.
Yeah.
Yeah, that the chromium oxidation works also. All right. Next one here, provide the reagents needed to carry out the transformation.
D.
A and C.
Yeah.
Yep. Yay, we got it right.
Can you just step through, like, briefly,
yeah, what's going on here?
describe what each one of those is doing?
Yeah, so the first one, A, you're making a Grignard out of this. And so you're getting a MgBr Grignard, and then reacting with CO2, the Grignard will act as a nucleophile to the CO2. And one of the main benefits of doing it this way is that you're increasing the carbon count by 1 doing it this way, which is what you want in the product. And then step 3 on there, the quench. And then for choice C, here, this is the first reaction is an SN2.
And then choice C, here.
I hear myself. Sorry. And then we have the acid hydrolysis of a nitrile, the second step. All right, number 6. All right, so this one here, it's similar to the previous one. We are extending the carbon chain by 1. I'm recognizing that by the last step here. So I think that the way you should start this out is actually drawing out the compound.
Yeah.
Which is basically this isopropyl group here. So what do you guys think? Is it A or C, do you think?
C.
Yeah, it should be C.
Yes.
Yep. All right, for number 7, so another similar type question. So the first step here, we're making a Grignard, and then we're extending it by 1 carbon, getting our carboxylic acid group. And then what does this last reaction do?
Reducing agent?
Yep, reducing agent. And so are we going to get an alcohol or an aldehyde from this?
Alcohol.
Yeah, alcohol.
Yeah.
Yeah, so by that alone, you could rule out all the other choices.
Yeah.
So choice C should be the answer.
Mm-hmm.
Yeah, so one tip I usually give my students about multiple choice tests is rule out wrong answers, so you have less choices to guess from.
I was confused on that one because it's 2-2, and I thought it would be 3. I guess I'm confused when sometimes the carbon on the carbonyl is a number 1 and sometimes it's number 2, right?
Yeah, but typically if you have a carboxylic acid, it's a carbon number 1. Or sorry, if you have a heteroatom, which is the propanol. Yeah, so we would have a carbon right here and then OH. So yeah, that is correct numbering.
I don't know why I can't figure it out.
You might be thinking of the lowest numbering rule that we have, possibly. All right, next question here. This is just a naming question.
B. That one was easy. That was just
Yeah.
Yeah.
naming.
Yeah, it looks like a pentanoate. The parent is this part. Wait, this part. So that's a 3-methyl pentanoate. So yeah, that's B. All right, next one.
D.
Yeah. D.
Yep.
That was the same again. Like,
More naming.
yeah.
All right, next one here. Rank the following carboxylic acids in decreasing order, most to least reactive.
This one was E. You gave us this chart in the lecture. Like,
Yep. So there were some freebies in here after all.
Yeah.
Yeah, that some of them are tended to be freebies.
Yeah.
So yeah, definitely remember the order. Your carboxylic acid, so your acid halides are the most reactive, followed by the anhydrides, and then amides are always going to be bottom of the list here.
Amides, yeah.
I think the only time it wouldn't be in the bottom is if they put like a ketone or something in there.
Oh, okay.
All right, next one here. So what does that first reaction do?
Isn't it like ozonolysis?
Oxidation.
It's an oxidation.
Yeah.
It's oxidation.
This is the ozonolysis reaction if we have an alkene, but we don't have an alkene here.
Right. Okay. Yes.
So remember that the benzylic H's are, if there is a H on the benzylic carbon, it is oxidizable.
Yeah.
And
I guess I just associated it with doing the same thing, basically.
yep. So you should be getting benzoic acid from the first step or the first reaction arrow.
Yeah.
The second one gives you, what does that do?
Gives an acid halide.
Yep,
It's
acid
the
halide,
basis.
and then what is the last part?
That's an alcohol, so it forms an ester.
Yes. So from that choice alone, you should have been able to rule out C and D.
Yeah.
And then the the chlorine here is kind of a distractor, I think.
Yeah.
So yeah, choice A should be the right answer for that.
Yeah.
Oh, by the way, I'm in a view that you probably can't see right now. This is an instructor view that I'm in right now. So, those that come to class are getting an extra benefit. Oop, showing the answer. All right, you guys all get B for this one?
Yeah.
Yes.
Yeah. So you're gonna get an esterification, but the ring's gonna open.
Yeah.
So we get an ethyl ester on one side, and then the carboxylic acid is the other for the leaving group, and that lines up with choice B. All the other ones don't make any sense. Like this is like what the heck is what the heck is E doing? What is that? All right. Next one here. Which of the following would not yield propylbutanoate?
D.
You think all of these would?
No. D.
Oh, sorry, I think it's an E. Yeah, D is not a good choice. What is wrong with D?
D is. Yeah. Okay. So we've got an amide, an alcohol, an acid. Yeah, I was trying to eliminate based on like A and B. Those ones, I already knew what they would do versus like an amine versus an acid halide or a carboxylic acid.
Mm-hmm.
Is there like a specific rule we can use for this? For this question?
Well, the main reaction we showed with amines where you have like a strong acid and a strong base and heat.
Right.
But here you could make the ester from this, but it would be a couple steps rather than one step. Where they're showing it all in one step.
Because initially it's not a good leaving group, right?
Correct.
That's the reason. Okay.
Yeah, you have to kind of bombard it to get it to make a good leading group out of it. Right. Next one here. Oop, I showed the answer there, but let's talk about it.
14 is B. So you have to form the aldehyde.
Yes.
Yeah.
And then
That's like a giveaway. That's the only one that has an aldehyde.
And then you have the OH left over.
Right.
Yeah, I think this would have been a much harder problem if it wasn't multiple choice.
Yeah. Yeah.
Or if they had aldehyde as all the choices.
Quick question on 13. For choice C, does that have a reaction? Will that alcohol substitute?
Yes.
Yeah, acid chloride will react instantly with homogeneity as well.
Not that one, the one below that one, the one that's the diketone.
Oh, the anhydride?
The anhydride, yeah.
Anhydride are second most reactive, so.
Okay, so that's just, that's clear.
Yeah.
Thank you.
All right. Did I skip one? Nope. All right, next one here. I'm just showing the answer there, but find the correct reagents. So I think this came up. This came up in the last stream that we talked about.
Mm-hmm.
Basically, you're going to get the Grignard adding on there a couple times. So the first mole equivalent gives you a ketone, and then the second mole equivalent gives you the alcohol.
And we're going, like, On this one, your cuprate won't attack an ester, right?
Not normally.
I just wanted to make sure.
So I think the textbook actually showed them making a ketone. Remember right?
It does with acid chlorides, I know. And anhydrides. Cuprates will react with acid chlorides and then anhydrides. I don't know any evidence of that.
Okay.
Yeah.
Is that a repeat? No, it's not a repeat. Thought for a second that was a repeat. All right, so the first reaction here is making a Grignard. You're then gonna put in carboxylic acid there.
Yes.
So extending by 1 carbon again. And then the next part here is the acid halide, and then we're making an amide from this.
Yeah.
Yeah, so it should have been between choices A and B. But A doesn't have the right carbon structure.
You got too many carbons on it.
Yeah, count your carbons. So. All right, now I start getting.
This threw me off. The SOCl2, the second one, that threw me off.
Yeah, I honestly had to look that one up after the quiz in order to figure out what it did because I don't remember that reaction at all.
So what does it do?
I know I learned it changes to a C triple bond N, but I don't remember that being something that we went over, so it was not in my notes.
It makes sense after the excess NH3. If I thought about it more, I guess it would have made sense, but I was just like, I'm going to ignore that. Just pretend it's not there. Did not work out for me.
All right, so. Oh, I do want to point out so the last reaction there. So like the final product is showing this ester, this ketone. I would basically assume on this question here that it meant 1 mole equivalent. I think if you had an answer that was probably like a tertiary alcohol, that probably would have been a better choice. But that's not one of the choices.
Actually, James, the second thionyl chloride turns the amide into a nitrile. Grignards only go once with nitrile.
Oh, okay. Sorry, I was thinking ester for a second.
Yeah. By the way, what other reagents could you guys use for the second SOCl2?
Could I do Diebol there to do the same thing?
Not to make it nitrile, no.
I feel a tiny bit lost. Is it possible that we could draw this one?
Yep, we can do it.
Yeah, they need to draw these ones out.
Yeah.
All right, let me. I'm going to switch the view on my screen here to be presenter camera.
I turned my view off.
You did. You're being
Yeah,
you're being camera shy.
I was. I finally learned how to stick this to your picture. There's this thing called tuning. The screen was jumping all over the place. No acting, guys.
I'm still trying to figure out how to do that on my cell phone, so you're not the only one who's.
All right, so the first part here, this is a chromium 6 oxidation with dichromate. So I'm going to put CR6.
We'll put in an R group instead of the...
Yeah.
Okay.
And I recommend that you guys do that also. If you see something that's not going to react, if you're writing a bunch of steps, this saves a lot of time.
We do that on our test.
As long as you put R back in the final answer, I don't mind. But I'm not sure how Hammond feels about that.
No, R
If you
group.
find your R in the mechanism, I'm happy.
Okay.
I love it when you make it smaller, it's easier to read.
All right, so we got that first part there, and then we have our thionyl chloride, which makes that. I'm not sure how this is showing up in the Zoom. Is it showing up okay in the Zoom?
It's awesome.
Okay. All right. All right. So what do we have next? We had excess ammonia. So what did that make again?
It will make an amide.
Yep. Then the next step here was another thionyl chloride. That was the one that you guys were confused on. Does this?
Now, what other reagents would you guys like to put there instead of thionyl chloride?
P4O10.
P4O10 would work. Or
And
Popple, POCl3.
oh, POCl3.
Yeah, Professor Mortimer ordered those last Tuesday.
A little bit too late, right? All right, so I think the last step was Grignard. Yep.
Yeah.
How many carbons is that? Just 2 carbons. Okay.
Mm-hmm.
All right, so the first step here is going to give us our Grignard on there, and this is our quench at the end.
Mm-hmm.
And then we get a, what do we get from this? We get a ketone, an acid.
A ketone.
Yeah. And then the same number of carbons.
Yeah.
That. And then you can just plug the R group back in and then pick out your answer.
This is D.
Yep, D was the right answer for that one. Oops. Hang on, browser. Browser, come on, switch.
Okay.
Here we go.
18 really did me in because all the examples, I mean, I still got it right, but the examples that we did, we had a carboxylate on the end of these, and all of these are alcohols.
No.
No. They're just the protonated form.
Okay. I thought they had to be exact.
No, no,
Well, if,
go ahead.
if you ignore the glitterine missing, the one end is always has an amine, the other end always has a carboxylic acid. So there's only one that actually sets up properly that way.
So,
if you go amine to the amide, to the amide, to the carboxylic acid, that's 3N prime to 2 prime.
Yeah, no, I got that part. It was the bottom portion. I can't remember which part it was. I think it was the asp part.
the aspartic acid.
Yeah, from the worksheet, it was not a carboxylic acid, it was a carboxylate.
Oh,
Yeah,
So
it's just the protonated. They're showing everything protonated here, and no
Yeah,
charges.
that's what threw me off.
Yeah, I'm looking. I have the chart up right now. If you guys can see it.
Yeah.
It's in the
So I
bottom.
just showed the closest to it. So got it right.
Okay. Yeah, whether or not you guys will go over this more detail in biochem, but they'll basically you'll have to work with the charges on the side chain too.
Okay.
A lot of stuff in here we just leave it all neutral.
Okay.
Which is the correct answer on that one? Just let's see.
See.
Yep. See. So what is wrong with choice D?
D as in dog?
A sec
Yeah.
butyl on the end.
Mm-hmm.
Sec butyl instead of isopropyl.
Yeah. So on a problem like this, what I would do is check the R groups, and then if those all line up with like say 2 choices, I would then start focusing on the actual chain itself, because the chain might be wrong. Like for example, B puts the amide on the side chain, right there, where that's incorrect. So, and if you were in my my one or yeah. If you were in a regular class, I'd make you guys draw this. You're missing out on all the fun. All right, so next one here, what is the predominant form of aspartic acid at pH of 1? So we are showing that right answer here, but I want to talk the logic of it. So what you need to do here is you need to know what the pI is of aspartic acid.
Mm-hmm.
So referring to this chart here, I do want to point out on the exam there was like one question where you need a PI, and I just give it to you in the question, so you don't have to look it up. I got a little bit of pushback about not giving heads up about this one. So aspartic acid is a 2.87 pi.
Mhm.
So what does that mean? If pH is below that, what does that mean?
It's protonated.
Yeah, it would be
Acidic.
Or
Yeah, so the way you want to think about it is if pH is below pi, it's protonated. If it's above pi, it's deprotonated. All right, and then the next one here, what is the predominant form of asparagine at physiological pH? So for this question, you need two things. First, you need to know what the pI of asparagine is. You also need to know what physiological pH is. I mentioned it when we talked about it, though, so it wasn't completely new material. I did mention it. Do you guys know what physiological pH is?
7.4.
7.35 to 7.45.
Yeah, so
Nice.
7.4 range. I mean, yeah, it fluctuates a little bit, but yeah, 7.4-ish. So we know that. So then you look at the handout. Asparagine is here, 5.4. So it should be deprotonated, right?
yeah.
And does E show the deprotonated version here? Is that wrong?
There's
No,
plus and a minus.
shouldn't see.
The answer is E.
But what is what? I think it's a mistake.
Yeah, shouldn't see, right?
Right. The amine should be protonated, the carboxylic acid should be an anion, and the side chain should be neutral.
The side chain should be what?
Yeah.
Yeah, that's right.
And that's the he has a. It did the side chain on to the left.
Yeah.
The
What is-
amine is protonated, the acid is deprotonated. Yeah.
I'm saying E is a zwitterion.
Yeah, that's what it's supposed to be. But the side chain is neutral. It doesn't have a proton on it. Because it's below the 5.1.
Yeah.
Wait a second. Double check.
So the two different amine groups have a different pKa.
No, the one is an amide group, and that's the side chain, and that one should be at a neutral.
Yeah, but
Whereas
the PI is 5.4.
Yeah, but the amine is still protonated at 7, so it should be NH3 plus, and then the carboxylic acid is definitely deprotonated.
I'm thinking based off what I covered though, it should have been C.
Yeah, that's why.
What do you have E? E looks like a neutral.
That's what I'm talking about. That's incorrect.
So when we looked it up, the asparagine, the pI of asparagine at room temperature showed us 10.76.
Maybe that's a mistake on the handout.
Yeah, because that's the only reason we chose E.
Hang on, let me.
I chose say.
Hang on. I can fix.
I didn't even have my sheet.
I
That
can
must have
easily.
been nice.
Points wise, I can easily fix this, guys. So don't worry about that. So I just want to make sure we're all getting the right answer. Yeah, this has it as 10.76 if you Google it.
Right.
So I'm gonna go ahead and I'm gonna change. So I think I'm gonna fix this to basically give it full credit regardless what you put. But based off what I taught and the PI that was in the chart, C is the correct answer. So you guys seeing this right now? Regrade options.
Yeah.
So I'm gonna mark this one.
Nice. That's nice. Appreciate that.
Do you know what the correct answer is?
Well, if the PI is actually 10,
Yeah.
Mm-hmm.
what do you guys think?
E.
Yeah. Wait. No.
Why?
No, the PI is 10, we're at 7.4. It should be protonated.
Right, so the NH3 is protonated.
Yeah, that's why we chose E.
There isn't one that seems like it would necessarily.
B.
fit.
B is protonated form.
B, yeah, I think B is right.
Yeah, so E is when you're at PI. When pH is equal to PI is choice E.
So are we supposed to expect that that amide group just won't protonate?
Correct.
Okay.
Yeah, amides are very weak bases. They're not going to protonate very easily. All right, guys. I'm going to go ahead and save this one. You should be getting a message soon about your grade being adjusted if you missed that question. All right, I'm going to go ahead and close this one out now and start the next one. All right, next quiz here. Which of the following alpha hydrogens is most acidic? Yeah, I got a better idea. So I think this time, let me try this a different way. So I'm gonna go back to assignments, and I'm gonna pretend I'm taking it, and we'll see what we get. Let's try it that way. All right, so that was this one, and then preview. Yep. So this should have been what you guys saw when you were doing it.
Yeah.
Yep.
It's B.
Why? Why the B?
Because it has, like, so I was looking at, like, in terms of more carbons, but also between 2 and 3, 3 is an ester, so that one didn't make sense, so 2 was the only option that made sense.
Yeah, remember we still can deprotonate alpha carbons on esters, but they require strong bases to do so.
Right.
Yeah, so I think the choice that should have came probably between 2 and 3.
Mm-hmm.
And then, yeah, 2 is definitely more. So hopefully I don't get it wrong. What do you guys think of this one? Which of the following is the most acidic?
C.
Let's see.
Yeah.
Because it's just surrounded by.
Carbon.
It's like triple alpha.
Yeah.
Yeah. I hear motorcycle. Yeah, I think it's C also.
Mm-hmm.
All right, next one. Which of the following are keto-enol pairs?
Okay, this one was D, for sure. This one was easy because the double bonds were all over the place and all the rest of them.
Yeah, this is another freebie question in my opinion.
Yeah.
I always like to throw a couple free. What I think are like. Are you paying attention at all?
Right. Like it's literally from the notes.
Yeah. All right. Next one here. Which of the following explains the equilibrium? So the way the arrow is, it's saying it's favoring the right side.
Right. Okay, so this one's E.
I think B and C.
Yeah.
Why A is not correct?
Why what?
Why A is not right?
That the enols are typically not more stable.
Because for this question, just for this one, enol is more stable.
Yeah, but it's saying their simple enols are more stable. That is incorrect.
Like if you only had one ketone.
Yeah.
The ketone
Oh, why is C, and why is C correct?
Both B and C.
Well, B makes sense, but C didn't. I just put B because C, I thought it could be, but then I thought, is it? I didn't think it was stabilized by intramolecular hydrobonding more than the other one.
Yeah, I've seen drawings of this where they show this H right here. I'm not sure if you see my mouse at all, but yeah, it comes over this way, and then you can have H bonding with the oxygen.
Because the hydrogen is like partial positive.
Yeah, so you can get intramolecular H bonding in this compound.
Yeah.
So
I think we put that in the notes too. Like we had an example like that, I think.
maybe in Hammond's notes. I don't think I typically go over that example, but I think it was in Hammond's notes.
It was in my notes.
Yeah.
When you have a beta diketone, 75% of the time it's in the enolate form in the bottle. And only 25% of the time it is staying in the diketone.
Yeah, so yeah, B and C are correct here.
Yeah.
All right, next one, predict the major product.
5 was very obviously 1 because it was the only alpha carbon that had a hydrogen where the chlorine would attach.
None of the other ones make any sense at all.
No.
There's like chlorines wherever they want.
Yeah.
They took carbon too.
Yeah.
Yeah, so I want to point out that we typically show this reaction with the base, but remember you can do it with the acid also. Because the H plus will make an enol, and that's nucleophilic, so that works. All right, still loading.
Okay. Number 6, this was the one that we said like got us.
All right.
Is this supposed to be C, this one? Yeah?
Yeah.
Okay.
Yeah, let me get it for showing on underneath the zoom. Yeah, let me move the zoom over this way.
But Professor, you said aldehydes usually undergo addition reaction.
They can, but that's not one of the choices.
So is that B? I was kind of confused. Isn't B?
Aldehydes can undergo addition reactions with the nucleophile. The bromine's electrophilic.
Oh, yeah. Okay.
So it'd be C.
Yeah, this is like the HVZ reaction, sort of, right? Ish, sort of. But yeah, C is the correct answer here. All right, next one. We've got bromine, PBr. What does that BR2 and PBr3 do again?
Just add the bromine.
To the alpha carbon.
Yeah. It'd be B.
That's Reformatsky, right?
It's HV, some reaction.
Yeah, hell of a hard to
Yeah.
Hell of a hard.
Yeah.
Okay.
Yeah. So the first reaction there is you're gonna get 2 bromines on there. You're gonna have an acid halide and then the alpha carbon bromine, and then to quench the water is gonna give you your OH.
Yeah.
Yeah. So choice 2.
So 3 is intermediate, 2 is primary.
Correct.
Oh, okay.
Right. Yeah, this is the iodoform reaction. You fix
Number
my-
8, is that what you're saying?
Yeah, number 8's iodoform. So you're basically going to get bromines adding on here into on the alpha carbon, and that becomes a good leaving group.
Yes.
Yes.
Yeah, you'll make compound 2, which then falls apart to compound 5.
Yeah.
Yep. So.
Because of that quench, the H2 plus.
Yeah.
So 5 was the answer, 2 was the intermediate.
Yeah.
Correct.
Intermediate, 5 is the answer.
So you need excess of both of those, right? Of 1.
Can you make the answer 1?
I did.
That is a 1 mole.
I did too.
Like if there's 1 mole of bromine.
Right, because that's what they said in the book, is that you need the excess, but anyway, I put 1 and I went fast through it.
Yeah, 1 is the first one. Yeah.
Hang on. Oh, let me do this. Now you know what it feels like looking for, going over a quiz in my class. They all look for mistakes. They can get bonus points back.
Bonus points!
That's what we're going to get after the final unit.
Yeah, this one has 5 marked as correct.
Yeah.
That would be the answer with excess.
So I'm going to mark the first option here, a word for both corrected and previously correct answers.
Right.
So yeah, so if you marked A on this one, it's going to give you points back.
So Professor Ormond, if you have excess, do you always write excess? Because I know people do that in different ways.
Yeah, I actually went and made sure of that on the exam because that was an issue with this one.
In fact, I think we even put in 1 mole or 2 mole equivalent.
Yeah.
Yeah, we were very particular on the exam. Hopefully we caught all our mistakes.
What do you guys think of number 9?
Number 9 is D because it doesn't have any alpha hydrogen, or it doesn't have any hydrogens on your alpha carbon.
That's correct.
Yeah.
Hang on, let me just... Which one are we on again?
9.
9, yeah. D.
Yeah.
Alright. So this one, predict the major product for the following reaction. I think this is probably a good one to draw.
Yeah.
So let me go ahead and draw this one out. So we have butanol, 1, 2, 3, 4. And then, what is that? Pentanol, 1, 2, 3, 4, 5. Yeah, on any of these questions here, if you're being given names, you should really draw them out, unless you're just that good. But all right, let's just over. All right, so here we're using hydroxide as well. So the first thing you should notice in this one here, this one has no alpha.
Can everyone mute, please? Because I keep switching and I can't see your screen on big. So if you mute, if everyone mutes except you, we can see you.
You can pin my picture also. That's probably better to pin it in Zoom. Actually, could Yui mute? That's where a lot of the noise is coming from Yui.
Okay.
Yeah. All right. Okay. So this one has no alpha hydrogens. This one does. So we're basically going to get substitution here. Or sorry, then 1, 2, 3, 4. So remember, for the aldol, we basically get a double bond. Instead of double bond O, it gets double bond alpha carbon, right? Like that.
Hey, Professor Moore,
Yeah.
they didn't do the condensation as the product.
Why not?
I don't know, it's not giving you your choices on the answer key.
Okay. So in that case, where would the OH be at? So I think this is a better answer, but it's not one of the choices. So based off the choices that were shown, they're not showing the elimination product. They're keeping the beta hydroxy. So the OH is here then.
Okay, so A should be the right answer.
Yeah, so now it's a matter of counting carbons. So it's saying 1 and 3. Oh, yeah, 3 is the self-aldol.
Yeah, I put A.
Yeah, I put A too.
I put
You twice.
Yeah, so choice 3 is the self-aldol. That's a possibility too. Are you guys seeing that?
A.
Yeah, but choice 3 is the self-aldol product with butanol. Right here, this one. That's the self-aldol product with butanol.
In other words, there were 2 right answers, 1 and 3.
Yeah.
Are they both? For some reason, I had the feeling that one of them was favored over the other, but are they pretty much just like they both are equivalent major products?
Almost.
Okay.
And why not the elimination products?
It's not the choices. It's not in the choices.
Just because it's not a choice. Okay, so A is now incorrect, or correct, will be considered correct.
One of the catches on ACS style questions is when they say aldo, it rarely means a condensation. They'll add the word condensation when they want aldo condensation. So, it's just a technicality.
So now A is the correct answer, right?
No.
It was A, 1 and 3.
Which is D.
Which is
I changed it to give you credit for both. So if you put D
okay.
previously, it'll still mark it as correct.
Okay. Oh yeah, 3 is right too.
I'm being nice now.
Did they get credit for all 3 answers?
You know what? I'm just gonna whatever for this one. Hang on.
A, C, and D.
A, C, and D.
And could a self-aldol always just happen? We just should assume that could always happen?
Yeah. Aldehydes can always react with themselves. The only exception is if there's a Michael addition, the Michael addition will always happen.
Right.
Right, this is another aldol, isn't it? Yeah.
Also, I love that the answer was the darkest choice.
Yeah.
This was like the same exact thing we did on our lab last week.
Mm-hmm.
So this one was good. D, yeah.
What do you guys think for this one?
A.
Yeah, A. It's the only one that made sense.
Yeah. What about this one? What reaction is happening here?
Oh, this one was the...
Wait, this one
The
was...
Claisen?
Claisen?
Claisen.
Claisen, okay.
Is it the intramolecular one though, or no?
No, it's reacting with itself. So the first thing you do is you deprotonate with this, get the enolate, and then that reacts with another equivalent of itself and trades out that for the OET.
Yes.
So yeah, so like if you're looking at the answer right here, this part right here is the original piece, and then this is the new part right here.
Yes. Yeah.
Which is this part right here. So, all right, so A for that one. This is a cross Claisen, I believe. Yep. Cross Claisen.
What is a cross Claisen?
You have more than one.
It's all the products, right?
Yep. All the above are possibilities. So you have to think about all the different options that can happen here. You have the with itself, each with itself, and then with each other. are different options. And then the way that they react to each other are also options. So like this could be nucleophile, electrophile, or nucleophile, electrophile. So yeah, that's 4 options. And then it's all options.
Alright, okay.
Yeah, if you want to go back and practice, I would use this one as a practice problem because it has like all the different options you could do. Yeah, all the above. What about this one? What did you guys get for this one?
Okay. So this was like the Dykman, right?
I believe so.
I got A.
Yeah.
Yeah, so just so you...
It could have been 3, 4, or 5 because there are too many carbons.
Yeah, so what's happening here is we're deprotonating right here, this alpha carbon, and then this is attacking this carbonyl.
Mm-hmm.
That's a 5-membered ring, and that lined up with choice A here.
Mm-hmm.
All right, so this is a straightforward one. Save the easier one for last, it looks like. So the main thing on the first part here, you guys have to deprotonate with LDA, but you have to remember which side it is.
LD substitutes.
Yeah. So and then the alkyl group's going to go here.
Yep. That's B.
Yep. I don't think I mentioned it here before, but you may see this temperature condition being pretty common in organic chemistry. This minus 78 degrees C. That's actually a pretty specific temperature. It's for dry ice with acetone. If you take acetone and add dry ice to it till it stops bubbling, it's at minus 78 degrees C. Super cold.
Quick question on that one.
Mm-hmm.
We're going over it as a group, and somebody found on the web that depending upon the temperature of LDA, it would cause favor the more substituted side. Have you heard anything about that?
We're gonna go with either or on this. So we're gonna say LDA favors least substitute.
No, I was just wondering, like in general, have you heard anything about that? Because it didn't make any sense.
This is all equilibrium here. So yeah, I can see arguments made for the more substituted to higher temperatures easily.
Yeah, I answered B. I'm just kind of curious if you would like.
Yeah, we're saying it's one or the other. All right, 17. What do you got to get for this one?
I got D.
So D is going to decarboxylate after this last step, right?
Yes. If there was heat, right?
I think it's gonna have to be the answer. Yeah. Oh, D. Oh. Yeah. So yeah. Oh, sorry. Yeah. If you had heat there.
Heat is missing. Yeah.
Yeah. So C would be the answer if heat was there.
Yeah.
Because that would decarboxylate.
Yeah.
So we have the diacid here. All right, and then number 18. This is kind of the same question again, sort of.
B.
It's happening twice though.
That's D.
So basically, you're getting the alkyl group on there twice.
Mm-hmm.
And then you do saponification, which is this product. Wait, so sorry. So after the first 2 reactions, you get choice 3.
Mm-hmm.
And then after the next reaction here, we get, is that even a choice? This one? It's choice 1.
Mm-hmm.
And then
Yes.
and then esterification, you get choice 4.
Yep.
Yeah. So all your intermediates are kind of in here. It looks like.
Mm-hmm.
And why does it not become B or number 2?
I was saying that so after you do your first couple of reactions, choice 2 is where you're at, and then that decarboxylates to become choice 1. And then the esterification makes the choice 4.
Mm-hmm.
I think we did one just or similar to this in class, didn't we? I think I did one like this during my last stream.
Yeah.
Yeah.
So what do you guys get for this one?
C.
C. Yeah.
Yeah, so just to make sure you guys are understanding here, this ring is coming from this part, that Br compound. That's basically your ring. and the reaction is happening twice. So the first time it happens, it's a straight chain, and the second one is the intramolecular version of it, giving you the ring, and then decarboxylation.
Yep.
And then last problem, acetoacetic ester.
D.
Yeah, I got D too.
So on this one, you can remember that these reaction sequences for the acetoacetic ester give you a ketone.
Mhm.
That ruled out everything but choice 4.
Yep.
Yep, choice 4. All right, let's hit save. All right. You guys have any questions?
Can you go over decarboxylation mechanism? Because that's I messed that up like 3 times on this. Just was not seeing it.
Well, hey, I'm actually going to stop the stream, but I'm gonna stay in Zoom. But I'm going to stop my stream real quick. So, yeah, for those of you guys and YouTube, you're ready to take the exam now, right? I wouldn't take it right away. I would make sure that you study first and do a lot of practice before you open that quiz, or exam rather. All right, so let me go ahead and stop this.